I'm Dr. James Alsup. I'm in the physics program inside of computer science, engineering, and physics. I'm the theoretical physicist for the program. In our major, I'm the theorist, and then we have an astronomer who looks at black holes, and then we have another faculty member who likes to study material band gaps. And so you sort of work your way in, and there's this progression. You pay your dues with the first intro classes, and then the second year you get to do modern physics, and that exposes you to the different directions you can go. At that point, you're really ready to start working with faculty members and sort of testing what it is that you want to do after you leave the program. The program got together and we came up with an FYE course, so a first year experience course called Tales from the Dark Side. It points you in the directions of modern physics and what you would be exposed to. So we try to get to big ideas about atoms, get to big ideas about black holes, and then push it to other extremes too, like the whole universe. Theory, where you use mathematics to make predictions. There's experiment, where you test the predictions and see if they hold up or look for new phenomena. Computational is sort of its own thing. So computational has grown in the last 20 years. At the small end, the smallest would be particle physics. You go into atomic physics, which would be a group of particles. Then you could keep moving up. There would be biological physics. Keep moving up, you get to electricity and magnetism, classical physics, planetary to solar system, and then eventually cosmology, which is the whole universe in itself. Yeah, we take pride in sort of giving a diverse perspective on physics. So they're not all there, but you'll be able to touch on every bit of it. And if you want the smallest, then you would come to me, as I do high energy theory. So I can do some quantum mechanics and quantum field theory and black holes as well. Every one of our students is given the opportunity to work with our faculty members. They come through us, they get a solid foundation in their coursework, and they also work with an individual faculty member. So we teach them how to do research and move on to grad school. We've had a lot of success putting students out. I had this excellent group of students where we were working on a binary black hole system. So it was two black holes were stuck. Normally the black holes will move. Ultimately, what we were wanting to do is look at the forces outside of it. Do they get compressed together? Do they get stretched apart? And it might lead to an understanding of planet formation and stuff like that. Other students, the ones that move into experimental approaches, they probably enjoy our capstone course. The students typically pick their own project. We give them pretty much free reign to figure out what they want to do and build it. I've never seen a student turned down from the opportunity to work in them. And we've prepared them to go on to graduate school and be extremely successful. We've got this physics lunch that we do about once a month. We hang around for a half a day, just shooting the breeze and seeing what our students are up to. They're all involved with research. We've been able to provide an experience that's as good as anywhere in the country. And they've been able to grow from that and continue on inside of it. You want to be comfortable with math. You want to make sure that you're comfortable learning. You're comfortable committing the amount of time it takes to learn, and you're curious about something. Being a little nerdy goes a long way in physics, I think.